Hi, welcome to the Olympiad geometry. Let's continue our study. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe to the channel. So here is XMO, which from 1970 IMO Longlists P11. Let A, B, C, D, and A prime, B prime, C prime, D prime be two arbitrary squares in the plane that are oriented in the same direction. Prove that quadrilateral formed by the midpoints of AA prime, BB prime, CC prime, DD prime is a square. So actually, this condition is not necessary, right? So if we have a square, let's say A, B, C, D here, and we have another square, which is A prime, B prime, C prime, D prime here, right? So we have AA prime connected, BB prime connected, CC prime connected, and DD prime connected. Right, so we can find the midpoint of AA prime and the midpoint of BB prime. Then midpoint of CC prime. Midpoint of DD prime. We actually can prove that this one is a triangle, is a square, right? And now we just think about this figure. It's actually very easy when we learn about the geometry transformation, but we didn't learn it yet. So let's just think about the very basic solution of this problem. Actually, the problem comes to this one. So if we have A, B, C here, right? And we find another set of A, B, C, or A prime, B prime, C prime. So here AB equals to BC, and we find another A prime, B prime equals to B prime, C prime, right? Then we connect to AA prime, connect to BB prime, connect to CC prime. And we find the midpoint of AA prime. We find the midpoint of BB prime. We find the midpoint of CC prime. Now the question becomes to, if we already know that angle ABC is 90 degrees, angle A prime, B prime, C prime equals to 90 degrees, right? Angle ABC equals to angle A prime, B prime, C prime equals to 90 degrees. And we know that AB equals to BC, A prime, B prime equals to B prime, C prime. The question is that, let's call this one A1, B1, and C1. The question is that whether we can prove A1, B1, right? This is B1. Whether A1, B1 is perpendicular to B1, C1, or angle A1, B1, C1 equals to 90 degrees, right? That's a question. And also whether we can prove A1, B1 equals to B1, C1, right? And the problem like this, it's basically, you can see we actually amplify the AB, or amplify the shape ABC, right? We amplify it, and also we rotate it. That's a geometry transformation method. But for this one, we can simply just make here B prime, A prime prime. And here we form a B prime, C prime prime, okay? Which B prime, A prime prime equals to B prime, A prime. And B prime, C prime prime equals to B prime, C prime, right? And we already know that B prime, A prime equals to B prime, C prime. So that means B prime, A double prime equals to B prime, C double prime, right? And that means these four segments are equal. Then if we connect, and also B prime, A double prime is in parallel with AB, B prime, C double prime is in parallel with BC, right? And we know that this is 90 degree, this is 90 degree, which means this angle equals to this angle. And then we know that triangle B prime, A double prime is congruent to triangle B prime, C double prime, right? And that's actually the way we solve it, because we think about the geometry transformation ways that we actually amplify this one and rotate it, right? So we split these two options. We split these two operations. We first rotate it back, right? And now we want to shrink it back, which means we want to connect A double prime. And this one is already there. Now we want to connect C double prime, right? Now think about the problem, like we already know that this triangle is congruent to this triangle, right? And we find the midpoint of A prime, midpoint of A prime. Then we can find the midpoint of A double prime, right? Let's call this point as A2. Similarly, we can find the midpoint of this one. Let's call it C2, right? So we have C1 here, C2 here. And we know that if we connect A to A1 and connect it to A1, B1, we connect A2, B1, right? We already know that A2 is a midpoint of A double prime. A1 is a midpoint of A prime. That means A1, A2 is in parallel and equals to half of A prime, A double prime, right? This one is in parallel. Maybe my figure didn't draw very well, but the point is that this one is half and in parallel with A prime, A double prime, right? And if you think about B prime, A double prime, it's a trapezoid. So we can calculate, we directly know that A2, B1 is in parallel with A prime, A double prime, B prime, right? So these two are in parallel, which means the angle are equal, right? This angle equals to this angle. Okay, now we take a look at this triangle here. We know C2, C1 is in parallel with C prime, C double prime, which means this one, the C2, C1 is in parallel and equals to half of C prime, C double prime. And also, because B1, C2 is in parallel with BC, and B1 is the midpoint of B prime. C2 is the midpoint of C double prime. That means B1, C2 equals to half of BC plus B prime C double prime, right? And also in parallel with it. Similarly, here, remember that we got B1 A2 is in parallel and equals to half of AB plus B prime A double prime, right? And we know that AB equals to BC. B prime A double prime equals to B prime C double prime, which means B1 C2 equals to B1 A2, right? B1 C2 equals to B1 A2. This one equals to this one. And we know that A1 A2 equals to half of A prime A double prime, which equals to C prime C double prime. So we can get the conclusion that A2 A1 equals to half of A prime A double prime, which is C prime C double prime, which equals to C1 C2, right? So this one equals to this one, and we know that this one equals to this one. Right? And we already know that A2, A1 is in parallel with A prime, A double prime. This one is in parallel with this one. Right? So now the question is that we just proved, we want to prove that A1 B1 equals to B1 C1. We know that this one equals to this one, and this one equals to this one. Right, now the question is that whether we can prove this angle equals to this angle. And this angle is actually C prime, C double prime, the angle formed by, it's this angle, right? Because this one is the B1, C2 is in parallel with B prime, C double prime. And C1, C2 is in parallel with C prime, C double prime, which means this angle equals to this angle, right? And we know that triangle B prime, C double prime, C prime is congruent to the triangle B prime, A double prime. So this angle equals to this angle. Actually, these four are equal, right? And look at this angle. This one is in parallel with this one. This one is in parallel with this one. That means this angle equals to this angle. Therefore, we have the conclusion that the triangle B1, A2, A1 is congruent to the triangle B1, C2, C1, right? And because because A2, B1 is perpendicular to B1, C2, and we know that this angle equals to this angle. So A1, B1 is perpendicular to B1, C1. And A1, B1, because of the congruent, A1, B1 equals to B1, C1. So we just prove that this one, the A1, B1 is perpendicular and equals to B1, C1, right? And therefore, we proved half of it. And for the other half, it's just as repeatedly using this method, then we can easily prove it. So basically, that's the idea how we prove the basic conception of the geometry transformation, which is a rotation. We can split it for the complex operation, we can always split it into the several simple operations and find the similarities of the figures. Okay, that's this problem. I hope you like this one. See you in next one. Thank you.